Dear students, good morning. We are in the last position, that is determinants, 18th part. This is the last one. One more problem is there in the last exercise 4.6. Okay, now in the starting we solved 4 problems. It is the 5th problem. The topic is what is asked in the heading, that is we have to find the given equations whether they are consistent or not consistent. When we say they are consistent, with what condition? Okay, na? Consistent and non-consistent or inconsistent. Consistent means the given equations are having a unique solution for x, y, z or x, y. If the equations are two in the variable x and y, they are having x and y having a unique solution. If they are having a unique solution, then those equations are called as consistent. If they are not having solutions, not unique solution, not first of all solution, then they are called as inconsistent. How can we say a particular set of equations are consistent or inconsistent? How can we say? By using the matrix method, already we solved some problems. That coefficient matrix A, that is its determinant is 0, that is it is a singular matrix, then the equations are not having solutions. As a result, it is called as inconsistent. If that A means where A is a coefficient matrix. Okay, I will give one more example, one more problem. Now you see, 5th problem. We are given the system of equations 3x minus y minus 2z is equal to 2, 2y minus z is equal to minus 1, 3x minus 5 is equal to 3. Okay, these three equations in the 3 variables x, y, z. That system of these 3 equations can be put in a matrix form. That is 3 minus 1 minus 2. These are coefficients of x, y, z. Here x is not there in the second equation, so its coefficient is 0. That means 0x plus 2y minus z. So 0, 2 minus 1. Here 3x minus 5 is there, but z is not given. So 3x minus 5y plus 0 into z. So 0 is their coefficient. And column matrix x, y, z. And 2 minus 1 3 is the answers. This is capital A and it is capital X and it is capital B. If you multiply, we get the same thing. Already we know it. 3x minus y minus 2z is equal to 2. 0x, that is 0 plus 2y minus z. That means 2y minus z is equal to minus 1. Yeah. 3x minus 5y plus 0z. That means 3x minus 5y is equal to 3. Yeah. It is also correct. So, those given equations can be formed into matrix. Where capital A is a coefficient matrix. That is important. First, we find the determinant. Determinant means we are calculated in the first row and column related. So 3 of 2 into 0, 0 minus 5 into minus 1 plus 5 minus into 5 minus 5. Okay, now 3 of 0 minus 5 minus 1 of. This method is know it well. Row and column relate 0 into 0, 0 minus 3 into minus 1 minus 3. Minus of minus plus 3. This is plus 3 is there. Minus 2 of this row and column related 0 minus 6. So 3 into minus 5 minus 15. It is plus 3 and minus 2 minus 6 plus 12. Minus 15 plus 15 is equal to 0. So determinant is 0. Det A is equal to 0. If det A is equal to 0 means A is a singular matrix. Okay. If det A is 0 means A inverse does not exist. that matrix A is not invertible matrix. Why? Because A inverse means 1 by delta into adjoint A. 1 by delta means 1 by 0. 1 by 0 infinity. Infinity is not a mathematical number. So it is not defined. So A inverse is not there. So A inverse does not exist. If inverse is not existed, then the system of equations are having no solutions. As a result, they are inconsistent. Okay, na? Like that, okay. So we solved 1, 3, 4, and 5 problem. 2 problems. Second problem is given as homework, I think. Okay, na? Go like this. Next one is solving the equation by using the matrix method. That is finding the inverse and solving the equations. Of course, they are if they are consistent, means they are having the solutions. We have to find those values of x and y. Okay, na? Yeah. Now we will go. Now we are going to solve the 7th problem. 1 to 5 are checking whether the equations are consistent and inconsistent. We solved it. Okay. Now 7 to 14 problems are solving for x and y by using the matrix method. Okay, na? Inverse matrix method. You see, we are given 7 is 5x plus 2y is equal to 4. 7x plus 3y is equal to 5. Only 2 equations, 2 variables. This can be written, the above, that means this one, can be written in the matrix form as this one. This is 5, 2, 7, 3. X, Y, column matrix. 4, 5, column matrix. Okay, now? This is named as capital A, capital X is equal to capital B. Where capital A is equal to 5, 2, 7, 3. A, capital A is equal to 2 by 2 matrix. Then det A. We have to find the first determinant of matrix. 5 is 15 minus 7 is 14. So 1. So det A is not equal to 0. It is not 1. It is 1, it is not equal to 0. So if determinant is not 0, it is non-singular. It is non-singular matrix. So it is containing invertible. Non-singular, invertible, inverse, consistent. Please try to understand. Non-singular, invertible, inverse, consistent. Otherwise, singular matrix, again, it is not invertible, not containing inverse. That means singular matrix, inconsistent. Non-singular matrix, consistent. Like that. So here, that A is 1. So A is not equal to 0, that A not equal to 0, so A is non-singular. As a result, A is containing inverse. It is consistent, it is existed. A inverse is existed for this A. Now, how can you find A inverse? A inverse is 1 by delta into adjoint A. A formula is there. 1 by delta into adjoint A. 1 by delta into, what is adjoint A? This is A. Adjoint A means A, B, C, D. You remember it. AD is reverse DA. And it is a sign differs. Plus is there, minus. Minus is there, plus. So, it is minus 2, minus 7. This 3 goes there and 5 goes here. So 3 minus 2 minus 7, 5. 1 by delta is 1. So 1 by 1, it is 3 minus 2 minus 7, 5. So as it is. Now, this is capital A, capital X is equal to B. We multiply on both sides with the A inverse. A inverse into A is I, we know it. A inverse into B is as it is A inverse B. I into X is X only. Identity matrix multiplies any matrix, that matrix only. It another. So X. X is XY. We know it. It is XY. A inverse already is there. This is A inverse. and B is 4, 5. Now you multiply 3 4 12 minus 10. Minus 7 into 4 minus 28 plus 5 into 5 25. 12 minus 10 is 2. Minus 28 plus 25 is minus 3. So xy is 2 minus 3. xy is column matrix, here also column matrix. Corresponding elements are equal. X is equal to 2, y is equal to minus 3. Like this, we have to find the inverse. What it may be? 3 equations or 2 equations. We have to find A, whether A is singular or similar, so that it is containing inverse or not. If it contains inverse, then we proceed like this. If it is not containing inverse, means that A is equal to 0, there it stops. That equation is not consistent, it is inconsistent. Okay, na? Like this. Okay. Yeah, now we are going to solve the 9th problem. 7, 9, 11, 13. Odd numbers I am taking. The remaining 8th problem, 10th problem, 12th we have to solve it. Otherwise we will solve in the last. Okay, the 9th problem. 4x minus 3y is equal to 3, 3x minus 5y is equal to 7. And this can be written in the matrix form as usual. 4 minus 3, 3 minus 5, xy, this is 3, 7. Which is named as A, x is equal to b. Where A is the coefficient matrix 4 minus 3, 3 minus 5. First we find the det A. Det A is equal to 4 into minus 5, that is minus 20. Minus of minus 9 plus 9. Minus 20 plus 9 is minus 11. Minus 11 is not equal to 0. So det A not equal to 0 means A is a singular matrix, non-singular matrix. That means A is containing a inverse. It is containing inverse. A inverse is existent. Yeah, okay. Then how can you find A inverse? A inverse is equal to 1 by det A into adjoint A. 1 by det A means it is minus 11. And adjoint A means if A, suppose A is A, B, C, D, na, then adjoint A, many times we solve. It is the elements of first diagonal can be interchanged, and the elements of second diagonal, they are negative. That is, if plus is there, minus is there, plus, like that. Okay, na? This is the thing. So A inverse is 1 by det A into adjoint A. This is minus 5 here and 4 here. Yeah. This minus 3 means plus 3. 3 means minus 3. So it is A inverse. Okay. Now, this is A, x is equal to b now. We are multiplying on both sides with A inverse. Then A inverse into A is I into x is x. A inverse into b. What is A inverse? 1 by minus 11, minus 5, 3, minus 3, 4. And b is already is there, 3, 7. Now, how can you multiply? Minus 5 into 3, minus 15. Okay, now, plus 3 into 7, 21. Minus 3 into 3, minus 9, plus 28. Minus 15 to 21 is 6. 28 minus 9 is 19. So, 6 to 19 is there. Now it is x means, capital X means, it is xy, this column matrix. It is 6 minus 6 by 11, it is minus 19 by 11. So x is equal to minus 6 by 11 and y is equal to minus 19 by 11. Okay, na? Like that we have to solve. Okay, na? Yeah. Okay, observe minute. 11th problem. 11th problem is, it is not 2 equations. 3 equations were given. You see, observe me. So 3 equations means 2, 1, 1 in matrix form. 1 minus 2 minus 1, 3 minus 5. That means x is not there. 0, 3 minus 5. Okay, now x, y, z column matrix, and 1, 3 by 2 is there. 3 by 2 and 9 is there. Yeah, okay. This is capital X, capital A, capital X, capital B. Okay, now you leave out this one. This side you leave out. Main one, this one. It is important. Where A is, this one is A. We know it. And we find that A. That A means 2 into this product minus this product. You observe me, my fingers. Minus 2 into minus 5, 10. Minus of 3 into minus 1, minus 3. Minus 3 is plus 3. Okay, now. Minus 1 of row and column deleted. It is minus 5 into 0. 1 into minus 5, minus 5. 0 into minus 1, 0. Again 1 into row and column is deleted. 1 into 3, 0 into minus 2. 1 into 3, 3. 0 into minus 2 is 0. So 30 into 2 is 26. Minus 5 minus 1 is 5 plus 5. This is plus 3. So altogether it is 34. That here is 34, non-zero. Non-zero. That is, it is a non-similar matrix. So it is containing inverse. A inverse is existed. That means in order to find A inverse means we need to find adjoint A. Please carefully observe. Adjoint A means first of all you find the cofactors of all elements. In order to find the adjoint A, we need to find the cofactors for all the elements. For 2, for 1, this one. Observe me now. You observe my fingers. 2, 1, 1. First row, second row, third row. Like that only you follow. First row elements. 2 is there. Next one. Next one. So it is a plus. Observe me. Plus, minus, plus, minus, plus, minus, like this. First you observe. Like that you put it. Okay, na? Alternatively. And here row, second row, third row. Only like that one. So cofactor of 2 is row and column is related same as. It is 10 minus of minus plus 3. So 13. So 13 plus 13. For 1 is row and column is deleted. It is minus 5 into 0. Observe me. You observe my fingers only. 1 into minus 5, 0. Minus 5. 0 into minus 1 is 0. This is here is there. Okay, na? I didn't mention the 0. So minus 5 plus 5. Again, for plus 1. Row and column is related. 1 into 3 minus 0. 3 minus 0 is 3 only. So 0. Okay, na? But it is plus 3. Next row. For 1 row and column is deleted. This one. 1 into minus 5, minus 5, minus 3. Minus 5, minus 3. So it is a minus of minus 8 plus 8. Again for minus 2. For minus 2, of course here is minus, leave it out. But according to this one, plus minus is coming on. So not about minus 2. It is a different one. So for minus 2, it is a plus of, you delete this one and this one. We get 2, 1, 0, 5, minus 5, 2 into minus 5, minus 10. 0 into 1, 0. So it is a minus 10. Okay, na? Again for minus 1. The determinant is, cofactor. Delete this one and this one for minus 1. 2, 1, 0, 3 is 6 minus 0. So it is minus 6. Again for 0. Okay, now you delete this one and this one. Okay, now we are having 1, 1, minus 2, minus 1. Now it is minus 1, minus of minus plus 2. Okay, now so it is plus 1. Like that we have to calculate. For 3 and minus 5, we can get 3 minus 5. Okay, like this. Now, the thing is, many problems we solve. So, directly I am giving. A inverse is 1 by determinant adjoint. We know that formula. 1 by determinant means 1 by 34. Okay. Adjoint A is, you please observe me, adjoint A means we replace the elements of capital A by its corresponding cofactor. For 2 we write 13, for 1 we write 3, we write 5, for this one we write 3. Okay na, 2, 13, 1, 5, for this one 3. But it is in a row, but I write it in a column, don't confuse. Okay na, or otherwise I will take it. If you have the doubt, I will write here. You see, first in order to find adjoint A, okay na, first we write the cofactors for the elements places. That is, it is 13, 5, 3 na, like this. We are inserting the cofactors in the place of elements. And it is minus 10, minus 6, 1. Okay na? Minus 10, not minus 10, just wait. It is 8, minus 10, minus 6. And 1, 3, 1, 3, minus 5. But all power t, that is a transpose. It is not directly adjoint A. Adjoint A means you replace the elements by corresponding cofactors and again you transpose. So I put transpose. Now it is 13, 5, 3, 8 minus 10 minus 6, 1, 3 minus 5 we will get. That is what I wrote here. Okay na? Is it correct? Yes, okay na? Like that. Now we come to this side. Now see, at last we find A inverse. A inverse is 1 by 10 into adjoint A. How can we find the adjoint A? We know it like that. Now you put it here. It is A into X into is equal to B. Ax is equal to B. Multiplying on both sides with A inverse means A inverse into A is I. X is as it is X. This is A inverse into B. A inverse is, what is A inverse? Here is there A inverse. 1 by 34 into A inverse is this one and B is like this. 1 by 34 as it is. Here I into X is X. Here 13 into 1 13. 8 into 3 by 2. 8 into 3 by 2. What is 8 into 3 by 2? Suppose 8 into 3 by 2. That is nothing but 4 into 3 now. That is 12. Okay now. So I wrote here 12. Again 1 into 9 as this 9. Okay, now like this. It is all arithmetic. Next 5 into 1 5. Minus 10 into 3 by 2. 10 into 3 by 2. 2 5s. 5 into 3 15. Plus 3 into 9 is 27. Okay. 3 into 1. Next row into column. 3 into 1 3. Minus 6 into 3 by 2. Minus 6 into 3 by 2. 3 2s. Okay na? 2 3s. Minus 3 into 3 9. Minus 9. Again minus 5 into 9. How much? It is minus 45. Now 13 plus 25. 12 25 plus 9 34. This is minus 10. 27 is minus plus 17 is there. Minus 6 minus 45. Minus 51 is there. Now 34 into 1 by 34. 34 cancels 1. 17 by 34, right? Because 1 by 34 into 7. 17 by 34 is 1 by 2. Minus 15, 1 into 1 by 13. You see, minus 51 by 34 is there. It is 17 threes. Okay, now minus 17 threes by 17 2s 34. 17 threes 51. Okay, Nana? So it is minus 3 by 2. Here capital X is XY. Already said. XY, Z. XY, Z. So X is equal to 1 and Y is equal to 1 by 2. Z is equal to minus 3 by 2. Corresponding elements are equal. Okay, na? Like this we have to solve. The total work is in finding the cofactors. Here is the important. Once again, you observe here. Finding for all the elements the cofactors, and then put as it is. Replace the elements by corresponding cofactors. After inserting cofactors, you transpose. Don't forget. Here is the transpose is there. Transpose it. Rows, columns, rows, like that. Then we get adjoint. That adjoint is divided by, multiplied by 1 by that A. Then we get inverse, like this. Okay, na? Yeah. Okay, na? 13th problem. It is 2x plus 3y plus 3z is equal to 5. And x minus 2y plus z is equal to minus 4. 3x minus y minus 2z is equal to 3. Yeah. That is the given equation. This can be written in the form of a matrix. Okay, na? These questions 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. It is minus 2. X, Y, Z column matrix. 5 minus 4, 3 is a column matrix. So that is Ax is equal to B. Okay, we will come again there. So where A is the coefficient matrix. 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. Okay, now first we find that A. That A means in the row, first row I am calculating. Row and column is 2 of 4 minus of minus 1. You observe my fingers. 2 of this row and column is related. 2 into minus 2 into minus 2 minus of minus 1 into 1. So 4 plus 1. Next minus 3 of row and column is related. This one. 1 into minus 2, 3 into 1. This is minus 2, minus 3. Next plus 3 of row, it is delighted. 1 minus 2, 3 minus 1 is there. 1 into minus 1, minus 1, minus of 6. Okay, now this is 5 to 10. Minus 5, minus 3, 15. Here 6 minus 1, 5, 5, 3 is 15. 15, 15, 30, 30 plus 10 is 40. So that A is 40 not equal to 0. So it is a non-singular matrix. So that A is invertible. It is containing a inverse. In order to find inverse, we need to find the adjoint A. Adjoint A is finding the cofactors. Here is the problem. Here is the arithmetic. Be careful. So writing the cofactors like this only. Follow it. First, I wrote all cofactors. Cofactor of 2, cofactor of 3, cofactor of 3, 1, no, minus 2, 1, no, 3, minus 1, like that. First I write. And then put plus, minus, plus 1, plus, minus, plus 1, like that. Alternatively. First you fill up this one. You see in a row, first row, second row, third row elements. Vertically you write it. Next, for this one 2, these are the elements. Minus 2 into minus 2, 4, minus half, minus 1, plus 1. Okay, now this is 5. Next for 3, row and column, deleted, 1 into minus 2, minus 2, minus 3. Okay, now 5. Next for this one, row and column is deleted, 1 into minus 1, minus 1, minus half, minus 6, so plus 6, so 5. Next for 1. Row and column is deleted, these are the elements, minus 6, minus half, minus plus 3. So this is minus 3, minus plus 3. Okay, Nana? Next. For minus 2, delete minus 2, that row and column, where they are having these elements. 2 into minus 2, minus 4, minus 9. Okay, na? Minus 2, minus 4, minus 1, minus 13. Okay, na? Like 1. For 1, this is and this one. So remaining elements are 2, 3, 3, 1. 2 into minus 1, minus 2, minus 9. Okay, na? It is minus 11 into minus plus 11. Again, like this, then I have to follow it. Many times, many problems we solved. It is our duty to find slowly. It is a difficult one, in my opinion. It is the students, all the students will commit the mistakes here only. Because putting minus, plus, multiplication, addition, everything is arithmetic. Be careful. Slowly you have to solve this one. Okay, now? Right. After finding the cofactors, observe. After finding the cofactors, adjoint A means, you observe me, adjoint A means you replace the elements by its corresponding cofactors. 2 for 5. Okay, now? For this 3, again 5. And for this 3, again 5. Okay, now? 5, 5, 5. Okay, now? Next. For 1 minus 2, 1. 3 minus 13. Okay, now? 11. Next, it is 9, 1 minus 7. But power T. That means transpose. We are refilling the cofactors in the place of elements. After that one, you transpose. Transpose means the row will become as column. The next row will become as next column, second column. Third row as a third column. Okay, now? It is okay. It is adjoint A into 1 by delta 140. 1 by 40. Now, we come to this side. Ax is equal to B means I am multiplying with A inverse on both sides and left side. A inverse into A is equal to Ix. A inverse into B. What is A inverse? Already we solved there. And B is that answers 5 minus 4 is 3. Now 5 5 is 25. It is minus 12. It is 27. It is minus 5. 13 4 is 52. 1 into 3 3. Okay, now 5 5 is 25. 11 into minus 4 minus 44 minus 21. Okay, now the summation. The 25 minus 12 13. 13 27 is 40. 25. Here it is 55. That is 80. Here it is minus 44 minus 21 is minus 65 plus 25 is minus 40. So 1 by 40 into 40, 1. 80 into 1 by 40 means 42 is 2. Minus 40 by 40 is minus 1. So capital X means it is x, y, z. So x is equal to 1, y is equal to 2, z is equal to minus 1. Corresponding elements are equal if two matrices are equal. So x1, y2, z minus 1. Like this we have to solve it. Okay, Nana? Yeah.